Hello guys, welcome to Hardcoder. In this video, we are going to see the Leetcode problem number 1706, where will the ball fall? Let's get into the question. So the problem statement is, you have a 2D grid of size m into n representing a box and you have n balls. The box is open on the top and bottom sides. So each cell in the box has a diagonal board spanning two corners of the cell that can redirect a ball to left or to the right. So a board that directs the ball to the right spans top left corner to bottom right corner and it is represented as 1. So let's consider a box. So let's consider a cell in a matrix, a cell in the box. So there are two types of boards. So first board will span from top left to bottom right. It is represented as 1. I mean, yeah, 1. And the other cell which spans from top right corner, so top right corner to bottom left corner is represented as -1. So top right corner to bottom left corner, it is represented as -1. So -1. We draw one ball at top of each column of the box. So each ball gets stuck in the box or fall out of the bottom. A ball gets stuck if V-shaped pattern between two boards is formed, or if a ball redirects the ball into either wall of the box. So finally, we need to return the array answer of size n, where which represent the resultant column at which the ith column dropped ball is reaching finally at the end. So if a ball gets stuck, we need to store -1. So we'll explain this three sentence. So it's nothing but we'll drop the ball at each column of the box, that is in the top, and each ball gets stuck if it each ball has a two possible ways, that is stuck into the box or fall out of the box. The condition for a ball getting stuck in the box is given, that is a V-shaped pattern between two boards, or board redirects the ball into either wall. So wall is, let's say wall, what is wall? So let's consider a box. They have mentioned the top and bottom. So before that we'll draw each cell. So this is the box, and they have mentioned that top and bottom are empty. So top and bottom are open, and each cell is denoted as, I mean, each cell will have spans, right? So let's see the spans. So when we consider this, a ball will be dropped here. The first ball will stuck here. So when we consider second ball, it will go to here, go to from here to here, here, here. So let's change the color. So firstly this ball will go to here and it will reach the final. It can reach it out. So the first ball will have first ball is stuck, so we have -1. Second ball reaches the column 0, 1, 2, 2. So answer array will store 2, and we'll drop the third ball. Send another color. So zeroth ball will get into it. So it will go down and it will reach the wall. So we'll have the answer as -1 of the current ball. So for the next ball, so we'll change the color. So for next ball, it will get stuck in the wall. It will go to the wall and get stuck. So this 2 will return, I will store -1. So the final answer will be what, -1, 2, -1 and -1. This will be the answer for this question. So this is what they are asked you. And how can we approach this problem? So we just iterate, we'll track the path of each balls and check for two conditions, and they have given the condition for ball getting stuck. So condition for ball getting stuck, the first condition is V-shaped pattern between two boards in the path, ball's path. And second is the ball hitting the board, that is wall. These are the two conditions, and it's nothing but we'll just have the approach for this problem will be to firstly, so let's change the color. So firstly we'll simulate the ball's path, and next each time we'll check whether the ball gets stuck or not. Ball stuck during each moment. So finally, if it's stuck, we'll store -1. If it reaches the end of the box, we include the column value. So this is the approach for this problem. So let's get into the coding section. There you'll get the clear idea how to code this approach. So firstly, we'll have an answer array. So answer movement of. So we're going to build for each column. So for each column, we're going to drop a ball. So we'll take the column length, which is grid of 0 dot length, and we'll start with each column. So we'll be using the j index to start from each column. So firstly, we'll drop from this column. So let's consider this in this case. First, we will drop ball in zeroth column, first column, second column, third column, and fourth column. So we are using a loop to simulate that. And finally, if so, finally answer of current column will be ball fall. Let's have a helper function ball fall column of it pass j and grid. Finally, we'll return answer. So now let's build up the helper function, which is ball fall column. So it will be having column and grid. So initially we'll have a row as 0, and while row is less than grid dot length, firstly we'll find the current direction. Current direction will be grid dot row and current column. So if it is 1, we are going to move to left. If it is direction is 1, it's a condition in which we need to check for left. So in left, we need to move to left. So in that case, we just consider. So let's see. So let's consider the given test case. So if we move on to left, if the ball is placed here, we need to check whether the neighbor board to the left is uh, in the opposite direction or not. If it is opposite direction, the ball will get stuck here. So in this case, if we drop a ball, let's have a yellow ball, and if we drop the ball, it is stuck here. So what is the condition when the left when we move to the left condition, left direction? So when we move to left direction, we need to check the immediate left neighbor of the current board. So if it is in opposite direction, that is which is -1, in case of this problem, we'll say that problem ball is stuck. So there is another case in which the ball gets stuck. It is nothing but when, let's say, the ball yeah, so let's consider this as same direction, and finally we'll have this. So this cell will have the same direction as previous cell. So when we drop ball, let's have a yellow ball. When we drop the yellow ball, it will go here and it will move here, and finally it gets stuck. So you can clearly see that the ball hits the wall. So there is no immediate neighbor to the current cell. So we can mention the current ball as stuck. So we'll have -1. The same scenario applies for other direction, which is top left to top right. So in this case too, the ball gets stuck here. So let's consider, yeah, when the ball reaches its current cell, it will reach the wall. So it will be hitting the wall. So the ball gets stuck. This is the condition which you are going to use. So you'll know it in the coding section. You'll get the better clarity in the coding section. So first, if the direction is 1, we'll check the immediate neighbor. So if immediate neighbor, so in order to get the immediate neighbor, it is right direction. So it is right direction. In case of right direction, we need to check whether the current cell is, that is current column is end. So if it's end, we are hitting the wall, or else we check if the current rows next column, which is the immediate right neighbor. If the right neighbor is in the opposite direction, we'll return -1. So in this case, we'll return -1, or else we'll just increment the column. We'll move to next column, and else if you are in the other direction, we'll check if the current column is 0. So when you are moving to left, you need to check whether the current column is the end. If so, column will be 0, or else we need to check whether the current rows left is opposite direction or not. So if it is opposite direction, we'll just return -1, or else we'll reduce the column and we'll increase the row. So finally we'll return the column. So when we reach the end of this while loop, we'll be able to come out of the column, I mean the come out of the box, and we'll store the corresponding column value. So let's check with sample test cases. Yes, getting accepted, and let's check with other sample test cases. Yeah, it's accepting, and let's submit it up. It's accepted. So the time complexity of approach is order of n into m. So this is the time complexity. So firstly, we'll the n is for a row. So for each m is for column. So each column will be going down and down. So it is n, and yeah, that is the time complexity. And space complexity is big of 1, which is constant. So So, is there any approach which will be more intuitive than this? So, the answer is yes. And how can we do this? So, here we have used a while loop to generate the simulation. So, here we can use a recursive function. So, how are you going to approach this problem using recursion? So, we can just have some slight modification to this helper function and also the code, so that our approach will be more intuitive in the recursion. So we'll pass the current row and current column. So we'll have as row and column. So we don't need this, and we don't need, we'll have this as a base condition. So we'll just cut it, and if row is equal to grid length, we'll return the column, and we'll delete this. So we just refactor the code. So in this we see we'll return ball. So what we are doing here is returning -1. So we'll return -1 here, or else we'll return ball fall column of row plus 1 and column plus 1 and grid. So we had column plus plus here. So we are just uh, removing the code, and we are passing it as a helper function. That is, we are incrementing the column and passing it the helper function. And current row is also increased. So first we have row plus plus here. So we are just including that is incrementing and passing it in the helper function. So here too we have a helper function return ball fall column of row plus 1 and column -1. Since we have column -1, we are replacing column -1, and we'll pass the grid. So I'll remove this unused quotes. So this is for right direction, this is for left direction. So let's check this. It's accepted. And how can we further efficiently solve this problem? So we can see that in some cases we may reach the row and column, the same cell from any other cells. So we are following this approach in order to use the pre-calculated values when we needed them again during the future calls. So for that we are going to use memoirs using the row and column. So firstly we check with the this approach is accepted, and we're going to memorize the values. So how to do that? Firstly we'll have a integer array, two-dimensional array, and we'll denote integer of grid dot length and it dot 0 dot. So if you have already recalculated the value, which will be dp of row comma call. When we already recalculate value, the value will be null, not equal to null. So in this case, we return the dp of row comma column, or else we need to store the do a recursive call and find the value. So yeah, we have store, and finally we'll return the dp of row comma column. So let's pick it up. Let's accept that. Let's submit it up. Let's accept it. And the time comes of which is same as order of n into m, and space complexity is order of n into m. And approach for this problem, recursion plus dynamic programming. So that's all about this video. Have a great time.